Good morning children, Sai Ram. In today's math session, we are going to continue with chapter 3, that is playing with numbers. This is part 2 of the chapter. In today's session, we are going to learn about the prime numbers and composite numbers. To understand this, let's look at this table and observe. Children, do you observe that number 1 has only one factor? In this table, 1 is the only number which has only one factor. Okay? Then there are numbers like 2, 3, 5, 7 and 11. These numbers have only two factors, that is 1 and the number itself. In case of 2, we have two factors, that is 1 and 2. 1 and the number itself. In case of 3, 1 and the number itself. And same in case of 5, 7 and 11. These numbers have only two factors, that is 1 and the number itself. So children, the numbers which have only two factors, that is 1 and the number itself, they are known as the prime numbers. They are divisible only by number 1 and the number itself. Okay, so these are called the prime numbers. Now what are composite numbers? The numbers like 4, 6, 8, 9, 10 and 12. Can you see that these numbers have more than two factors? In case of 4, we have three factors, 1, 2 and 4. In case of 6, there are 4 factors. In case of 8 also we have 4 factors. In case of 9, there are 3 factors. And in case of 10, we have 4 factors. And in case of 12, we have 6 factors. So all these numbers which have more than 2 factors are known as composite numbers. Now let's look at the definition of prime numbers. The numbers whose only factors are 1 and the number itself are called prime numbers. Now let's look at these examples. The factors of 2 are 1 and 2. Then the factors of 3 are 1 and 3. The factors of 5 are 1 and 5. And the factors of 7 are 1 and 7. Similarly, the factors of 11 are 1 and 11. That means the factors of these numbers are 1 and the number itself. So these numbers are known as the prime numbers. The numbers 2, 3, 5, 7 and 11 have only two factors, that is 1 and the number itself. So they are called the prime numbers. Now let's look at the definition of composite numbers. The numbers having more than two factors are known as composite numbers. Look at the examples here. The factors of 4 are 1, 2 and 4. Similarly, the factors of 6 are 1, 2, 3 and 6. The factors of 8 are 1, 2, 4 and 8. The factors of 9 are 1, 3 and 9. 3 factors. And the factors of 10 are 4, that is 1, 2, 5 and 10. So the numbers 4, 6, 8, 9 and 10 are having more than two factors and they are called the composite numbers. The numbers which have more than two factors are known as composite numbers. And what about 1? 1 is a natural number which is divisible by only itself. It has only one factor, that is number itself. 1 is considered neither a prime number nor a composite number. Now let's try to remember these points about the prime numbers. 1 is neither a prime number nor a composite number. 2 is the smallest prime number which is even. Then every prime number except 2 is odd. Now let's know what are perfect numbers. So the numbers, when we find their factors and add all their factors, if the result is twice the number, then it is called a perfect number. So any number for which the sum of all its factors is equal to twice the number, then it is called a perfect number. Let's look at the examples to understand this. The factors of 6 are 1, 2, 3 and 6. If we sum up all these numbers, 1 plus 2 plus 3 plus 6, we get 12. And 12 is 2 times 6, isn't it? So 6 is a perfect number, isn't it? So the sum of factors of 6 is twice the number 6. Therefore, number 6 is a perfect number. Let's take one more example. Let's take the factors of 28. What are the factors of 28? They are 1, 2, 4, 7, 14 and 28. When we add all these factors of 28, we get 56. And 56 is nothing but 2 times 28. That is 2 multiplied by 28. Isn't it? So the sum of the factors of 28 is twice the number 28. So 28 is also a perfect number. Now let's know what are even and odd numbers. Children, you have learned about the even and odd numbers in your previous classes also. But let's just have a quick revision of what are even numbers and what are odd numbers. So even numbers, all the multiples of 2 and all the multiples of 2 are known as the even numbers. And also the numbers which have 0, 2, 4, 6, 8 at their ones place are known as even numbers, isn't it? So let's look at this. These are the multiples of 2. These are all even numbers. 2, 4, 6, 8, 10, 12, 14 and so on. These are all even numbers, multiples of 2. Similarly, 3 and 4 digit and 5 digit numbers which have 0, 2, 4, 6, 8 at the ones place, like here 0, 2, 6, 8, these are known as even numbers, which have the even numbers at their ones place. Okay, so 2 is the smallest prime number. It is even number. It is the smallest prime number. It is the smallest even prime number. All the other prime numbers are odd. So 2 is the only even prime number. Now, what are odd numbers? The numbers other than multiples of 2 are called odd numbers. And what are these numbers? These are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and so on, isn't it? And also the 2, 3, 4 and 5 digit numbers which have 1, 3, 5, 7, 9 at ones place are also odd numbers. Like the numbers here, 857 has 7 at ones place, and this number 6359 has 9 at ones place, and this number 4231 has 1 at ones place. So all these numbers which have 1, 3, 5, 7, 9 in their ones place are also called odd numbers. Alright, all the prime numbers are odd except 2. Now let's know what are twin primes. Children, we have learned about the prime numbers. What are the prime numbers? They have only 2 factors, that is 1 and the number itself. That means it is divisible by only by 1 and the number itself. So these are the prime numbers. Then what are twin prime numbers? The 2 prime numbers, if the difference between them is only 2, then they are called twin primes. Okay, let's look at the examples. Here we have 3 and 5. 3 and 5 both are prime numbers and the difference between them is 2. So they make a pair of twin primes. Similarly, number 5 and 7, the difference between these two prime numbers is also 2. Okay, so they are also twin primes. Then 11 and 13, the difference between these two prime numbers is 2. So they also make a pair of twin primes. 17 and 19 are also twin primes. Similarly, we have 29 and 31 which are twin primes. 41 and 43 and 59 and 61 and 71 and 73. All these numbers are pairs of twin primes, okay, between 1 and 100. Now, children, we have learnt about the prime numbers and the composite numbers. We know that prime numbers have only two factors, that means 1 and the number itself, and composite numbers have more than two factors. Now, is there an easy method to find all the prime numbers between 1 and 100 without actually finding the number of factors of each number? Yes, there was a Greek mathematician, Eratosthenes, who gave this sieve of numbers which by which we can easily know the prime numbers without actually trying to find the number of factors. Okay, so who was Eratosthenes? He was a Greek mathematician. Also, he was an astronomer and geographer. He invented a method to find the prime numbers. So, what is this method? This method is known as sieve of Eratosthenes. Okay. So, how do we find the prime numbers between 1 and 100 by using this Eratosthenes sieve method? Let's check this. In step 1, what we do, we have to write the numbers between 1 to 100 in a table. Alright. And in step 2, we have to cross out 1. Why? Because y is neither a prime number nor a composite number. So here we have a table of numbers 1 to 100 and we have crossed out 1 as it is neither a prime number nor a composite number. Then step 3, what we do, we encircle number 2 and cross out all the multiples of 2, isn't it? That means all the numbers which are divisible by 2 are even numbers, isn't it? So we will cross out all the even numbers which are multiples of 2, isn't it? So we have in this table, we have circled the number 2 and crossed all the even numbers. That means all the multiples of 2 we have crossed out, like 12, 22, 32, 42. All the even numbers we have crossed out. Now, so we have also removed the crossed out numbers. So what we are left with? We have 2, 3, 5, 7 and 9 and the other odd numbers here. Okay. Now in the next step, what we do? We encircle 3 and cross out all the multiples of 3. So let's do that. We have circled 3 here. Here we have circled 3 and cross out all the multiples of 3. That means 21, 51, 91. Similarly 33, 63, 93. Alright. So these are all multiples of 3 which we are crossing out. 15, 45, 75 and then 27, 57 and 87 also. Alright. So we have, and there are more numbers like 39, alright, and 69 and 99. These numbers also we have crossed out, isn't it? 3 is even, 2 is even. On all the crossed out numbers, they are composite numbers. 2 and 3 are, 3 is not even. 2 and 3 are prime, and all the other crossed out numbers are composite numbers. All the multiples of 2 that we have removed and also the multiples of 3, these are all composite numbers. 2 and 3 are prime numbers. Now in this step we have removed all the multiples of 3 also. They are all composite numbers. We have removed them. Now what we do in step 5, we encircle 5. 5 is a prime number. It has only 2 factors. So we will encircle 5 and cross out all the multiples of 5. Isn't it? So what we do in the next step, we cross out all the multiples of 5. So in step 5, we encircle number 5 and cross out all the multiples of number 5. Isn't it? That is 25, 35, 55, 65, 85 and 95. We will cross out all the multiples of 5. 5 is a prime number, whereas all these multiples of 5, they are composite numbers. Now in the next step, we have also removed the composite numbers, the multiples of 5 also we have removed from the table. Now what we do, we go to number 6. In step 6, we encircle number 7. In step 6, we will encircle number 7 and cross out all the multiples of number 7. Isn't it? So here we have encircled number 7 and we have crossed out the multiples of 7 that are, those are left, that is number 77 and 49. Alright, we have crossed out these numbers. These are multiples of 7 or they are composite numbers. Now these numbers are removed and these what are left on the table, they are all encircled numbers. All these encircled numbers are the prime numbers between 1 and 100. So this is the method given by the mathematician Eratosthenes to find out easily the numbers between, the prime numbers between 1 and 100. So let's have a proper look at the sieve of Eratosthenes. Here number 1 is crossed out, okay, and the encircled numbers, the numbers which are encircled like 2, 3, 5, 7, alright, 11, 13, 17, 19. These all numbers are prime numbers, and the crossed out numbers like 4, 6, 8, 9, alright, 12, 14, 15 and all these numbers which are crossed, they are composite numbers. So with this method we can easily remember the prime numbers between 1 and 100. Alright children, with this we come to the end of the session. Please try to practice this table, this sieve of Eratosthenes, and learn the prime numbers and the composite numbers properly. And also remember that 1 is neither prime or nor composite, and 2 is the only even prime number. All the other prime numbers, they are odd. With this we end this session. We will learn more in our next session. Till then, bye.